Alright, so this is our setup for the titration experiment. We have our burette, which is filled with our known concentration of sodium hydroxide, which for today is 0.1 molar. And down below we have our beaker, which will contain DI water and our unknown concentration of hydrochloric acid. And we prepared this by adding 60 milliliters of DI water and transferring 10 milliliters of the unknown concentration of HCl. And it's okay that we're mixing the hydrochloric acid solution with distilled water, because the only thing that matters is the moles of protons that gets added. Setup wise, we have our drop counter, which is connected to the iPad with the AirLink, and our wireless pH meter. So the drop counter will literally count the drops of sodium hydroxide that get added from the burette, and the pH meter will record the pH of the hydrochloric acid solution as we're adding our drops of sodium hydroxide. Now make sure to calibrate your wireless pH meter and to rinse your burette with sodium hydroxide solution. So let's go ahead and start recording data on the iPad, and we see that there's only one data point generated. Our y-axis is pH and our x-axis is drop count. So since there's no time component, we're only going to record data once we add drops. And our initial data point has a pH of 1, which makes sense because our HCl solution is acidic.
So let's go ahead and start the experiment. Let's add the sodium hydroxide. So as you can see here how we have the drops, and here we have the pH. So initially the pH is acid, and as you increase the number of drops of sodium hydroxide, the pH is going to slightly change, not so much, because here we are adding sodium hydroxide, but we have a lot of moles of hydrochloric acid. So initially this is like an excess reactant. So when you reach about 210 drops, your pH is going to start changing. As you can see here how it slowly goes up, and all of a sudden it changed to basic pH. So it's going to pass the neutralization point, which is here in 7. Keep adding sodium hydroxide until you reach a pH, a constant pH more or less of 11.5. So now we have to think of how we are going to do the calculations. So we want to know how much volume of sodium hydroxide we use to reach this point, which is the neutralization point. And to do that, the first thing we need to do is we need to know, could you please hold this? Thanks. We need to know what is the volume of each drop of sodium hydroxide. So to do that, we are going to go here and we are going to say, okay, how much volume of sodium hydroxide we use. So you go to your burette and it's going to be about 16 milliliters. And then you're going to say, okay, how many drops I use? So we use about 310 drops. So we are going to divide that total volume, or the final volume that you use, divided by the number of drops, and you get 0.053 milliliters per drop. Now, how many drops I use to reach the neutralization point? So we use 210 more or less, right? You go down here, or 205. I chose 210, but you will know that clearly later. So I'm going to multiply 210 drops for the volume of each drop to obtain the number of milliliters of sodium hydroxide that we use for the neutralization or to reach this point here. Now, knowing the volume of sodium hydroxide, I can multiply by the molarity, because that's the known, 0.1 molar. So you get the number of moles of sodium hydroxide, which is 1.1 10 to the negative 3 moles. Since the reaction is 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide, the number of moles of hydrochloric acid that we have in the beaker are going to be the same. So it's going to be 1.1 10 to the negative 3 moles of hydrochloric acid. Now, to know the concentration, we just divide the number of moles by 0.10 liters, which is the volume that we use initially of the solution of hydrochloric acid. So we get more or less 0.1 molar. So after you reach the point here, you just stop the iPad and you can go downstairs to finish your calculations, because you want to know the concentration of both the species at each point in the graph.